Welcome to my channel on chemistry lessons. Please make sure you like and subscribe to make sure you don't miss out on future content. So this video is aimed to be a second year A-level chemistry topic, and it's the first lesson in a series, and it's the first lesson on rates of reaction. So we're going to look at these three things. We're going to look at what is meant by the term rate of reaction. We're going to look at units that we can use to measure the rate, and we're going to recall the factors that affect the rate of reaction with an explanation of how and why they do that. So what is rate of reaction? Well, the term rate is a measure of how fast something occurs. So your rate of speed, for example, driving a car, we tend to use miles per hour or kilometers per hour. It's how much distance you travel per unit time. So how many miles do you travel per hour? How many kilometers do you travel per hour? Perhaps in physics calculations you'll use meters per second. It's how many meters you travel in 1 second. So it's to do with time, how fast something happens or how slow something happens. So if we was looking at a chemical reaction, it's no different. It's how fast that would take place over time. And there's lots of different ways we could measure that. We could measure how fast a product is being formed. So we could measure the rate of formation of a product. Or we could measure how fast a reactant is being used up. And that all really depends, I suppose, on the specific reaction. There's no right or wrong way to measure rate. You would choose your method looking at your reaction. For example, if one of the products being formed was a gas, you could collect the gas and measure the volume being produced per second. Perhaps one of your solids, so you've got two solids to begin with, and perhaps because you're making a gas, the mass will go down, so you could record the decrease in mass of the reactants. Or again, if one of the products was coloured and both of the reactants were colourless, you could use colorimetry to measure the rate of change of colour. So there's lots of different ways you can measure rate. There's no right or wrong way. You have to use the correct method that suits the reaction in front of you. How can we measure rate then? So there's lots and lots of different ways we could measure rate. We could measure, if it was a gas being formed, centimetres cubed per second. That would be a suitable unit. We could, if the mass of a reactant was decreasing, we could measure the change in mass per second, which is grams per second. Or we like to use the term moles in chemistry. We could use moles per minute. It's any amount of substance divided by time or per unit time. So we could do moles per second. We could do moles per minute. No difference. Okay. Obviously the values would be different, but these would all be suitable units for rate. So again, there's no correct way of measuring or correct units. There are several different units that you could use. However, we are going to stick and we're going to focus on this unit, moles per decimeters cubed per second. We're going to measure the rate of change of concentration. So moles per decimeters cubed, that's a concentration per second. And we're particularly going to focus in these future videos on the rate of change of concentration of the reactants or several different reactants. So we're going to study in particular the rate of change of concentration. Final thing we're going to look at in this video then, we're going to look at the factors affecting the rate of a reaction. You may recall from year 1 chemistry or possibly even GCSE studies and earlier that these are the three factors that will affect the rate of reaction. I've underlined the top two because these are the two that we're going to take into future videos and focus an awful lot more on. But I'm going to remind us of these 5 factors. So, an increase in concentration means the particles are more crowded. We've got more particles or more reactant particles in the same volume, which means the particles are more crowded. This leads to more collisions. This means that there will be more successful collisions and a faster rate of reaction. Let's look at temperature then. So an increase in temperature means the particles will move faster. this will lead to more collisions. The collisions will also have more energy, because not only do they collide more, often they will have more energy because they are moving faster. This means there will be more successful collisions and a faster rate of reaction. Let's take a look at surface area then. If we increase the surface area, this means that there's more area for collisions to occur. This will lead to more collisions. The collisions won't have more energy, so I'm removing that one. But the fact that there's more collisions means that there'll be more successful collisions and a faster rate of reaction. Now, before I move on, it's important to point out that surface area, a powder will have more surface area than larger lumps. So the more you break a substance down, the bigger its surface area. That's assuming it's the same mass, of course. Obviously, a smaller mass, you're changing two variables there. So the same amount of substance, but one being a powder and one being larger lumps, the powder has bigger surface area. You're increasing the surface area there if you crush something up. Okay, next, let's take a look at pressure. Notice this is gases only. So it's gases that are affected by a change in pressure. If we increase the pressure, the particles are more crowded. This is just the same as increasing the concentration of a solution here. So it's the same explanation that I'm giving. An increase in pressure, particles are more crowded. This leads to more collisions, and this means that there will be more successful collisions and a faster rate of reaction. Finally then, let's take a look at what a catalyst does. Now, a catalyst, what it does is it offers an alternative reaction pathway with a lower activation energy. So what this means, it doesn't mean there's more collisions, it means that the greater proportion of the collisions will be successful. So perhaps without a catalyst, only 20% of the collisions are successful. With a catalyst, there's going to be more than 20% of the collisions successful, so it increases the proportion of collisions. You may recall in year one that you looked at the Maxwell-Boltzmann distribution on this, and you could explain it using a graph. So offers an alternative reaction pathway with a lower activation energy, therefore a greater proportion of collisions will be successful. This means that there will be more successful collisions and a faster rate of reaction. I'm making a point with these cards here that I'm actually using the same sentences over and over again. I've used these bullet points several times. In fact, this last bullet point has been used in every single one. Okay? That's it for this video. The next video in this playlist, video 2, is going to start looking at the orders of reactions. So we can work out what does the order mean of a reactant. So the order of reactant A and the order of reactant B, and the overall order of a reaction. So that's a year 2 topic. So make sure you look out for the other videos in this playlist.